Good morning, children.
Good morning, ma'am.
Good
Good
morning.
morning, ma'am.
Good morning, ma'am.
Good morning, children. Good morning.
Done with the homework, ma'am.
Homework. Yes. Had I shared the answers or no?
Ma'am, the assignment, ma'am. You told to write it in our classwork note, ma'am.
Correct. So I think I already shared the answers, no, on WhatsApp with you.
Yes, ma'am, you shared.
All right. Yeah.
Yes, ma'am.
Yeah. So today we are starting a new chapter, triangle and its properties. So you know most of it. Let me check. Now this question is to Mritika. Mritika, name the triangle. Name this triangle. How do you name this triangle, Mritika? Deepshika, how will you name this triangle?
Ma'am, ABC, ma'am.
Triangle ABC. Is that the only way of calling this triangle? Triangle ABC? Can I say triangle BAC?
Yes, ma'am.
Yes, ma'am.
Can I say triangle CBA?
Yes, ma'am.
Yes, ma'am.
Can I say triangle CAB?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So we have these letters A, B, and C. They can come in any order. Just that you should make use of all these three letters A, B, and C. You must make use of all these three letters A, B, and C in any order. In any order, you should not repeat anything. You should not write A, B, C. You should not repeat any letter. There are three letters A, B, and C. You must use all the letters and only once, any order. And that will tell us the name of the triangle. So triangle CBA, triangle ABC. All right. Now we have, so this is how we name a triangle. This is how we name a triangle. And this is the symbol. Okay, so we say triangle. This is a symbol for a triangle. Triangle ABC. Triangle ABC. Now, a triangle has 6 elements. A triangle has 6 elements. And they are the 3 sides and the 3 angles. The 3 sides and the 3 angles make the 6 elements of a triangle. Now, which are the 3 sides of this triangle?
Ma'am, AB,
Side.
AC, BC, and CM, ma'am.
Okay. So again, AB, you can say side AB. What is this? This is to represent a line segment. Every side is a line segment, right? So we use the symbol line segment AB, which is nothing but the side AB. You can also call it as line segment BA. AB, BA, both represents the same side. See here, AB, BA. Both represents the same side. Yes or no?
Yes, ma'am. They both represent
Yes,
only
ma'am.
one side, ma'am.
Yeah.
Yes,
BC,
ma'am.
line segment BC, line segment CB. Same side. This is the side. Line segment BC or line segment CB. And then we have line segment AC. Or you can also call it line segment CA. So this does not mean that the triangle has 6 sides. The triangle has only 3 sides. Each side can be named in 2 ways. You can say side AB or side BA. Both represents the same side. side AB or side BA. Line segment AB, line segment BA. Then this is another side BC or side CB. Both represents the same side. So this is, say, the second side. Then line segment AC or line segment CA. Line segment, you all know this. Line segment like this, correct? You know this, right? Line segment, and under that you
ma'am.
should write AB. Sorry.
Ma'am, a line with two ending points and below there should be any capital letter to represent the side, ma'am.
Yeah. So AB, BC, and AC are the three sides of triangle ABC. So these make the three elements. Of the six, these are the three elements. The three sides are the three elements out of the six elements. Now the remaining three elements are the three vertices. Vertex A, vertex B, vertex C. This is the vertex A. This is the vertex A. And this is angle A. This is the vertex B. And this is angle B. This is the vertex C. And this is angle C. This point is called the vertex. Vertex A. This is the point. This point is called the vertex. Vertex A, vertex B, vertex C. So the six elements, sorry. The six elements of a triangle are the three sides and the three vertices. 3 plus 3, 6. The three sides, the triangle has three sides and three vertices. 3 plus 3, 6. These six make the six elements of any triangle. All right. Now, tell me, how will you, now when we say angle A, how will you represent angle A? I can write angle A like this. What are the other ways of calling angle A?
Ma'am, like BAC or CAB. Like
Yeah,
angle BAC or angle CAB, ma'am.
correct. Angle, yeah. So angle A can also be called angle BAC or angle CAB. Yes, others, tell me angle B. Angle B can also be called
ABC
ABC
and
and
C.
CPA.
ABC, ABC,
And CBA, ma'am.
and CBA.
And selected for angle C.
Yes, Nandana. Yes.
Ma'am, BCA and ACB, ma'am.
BCA or
ACB.
ACB. No, somebody who does not understand, you should ask me. Is it visible? Whatever I'm showing you on the slide?
Yes, ma'am. The annotations are visible.
Yes,
Yes,
ma'am.
ma'am.
Very good.
Yes, ma'am, they are visible.
All right.
Ma'am,
So
because of
these,
triangles having three angles, they are named as triangles, ma'am.
yeah, okay. Why triangle? Because tri meaning three. Any doubt with naming the angles, children?
No doubts,
No
ma'am.
doubt, ma'am. No doubt, ma'am.
All right. So what we saw so far is about the six elements, how to name a triangle, and what are the six elements. A triangle has six elements, three sides and three angles. So we know that, or we understood that every side can be represented in two different ways. You can say side AB or side BA, side BC or side CB. Both represents the same side. Side AC or side CA. So the sides can be named in two different ways. When you come to the angles, the three angles, see, you can say angle A, or you can say angle BAC, or you can say angle CAB. These are the different ways of calling angle A. Angle A can be called angle BAC, angle CAB. BAC or CAB. Likewise for angle B and angle C. So these are the 6 elements. The 3 sides and the 3 angles make the 6 elements of a triangle. Now let's understand what is the sum of all the 3 angles of a triangle, children?
180 degree, ma'am.
180 degree, ma'am.
180 degrees. The sum of the 3 angles of a triangle is equal to 180 degrees. All right. Now we'll understand the meaning of this term altitude. Altitude. I'll share the notes with you. You don't have to write anything now. I'll share the notes. Altitude. 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 Now take any triangle. How do you classify triangles based on the sides?
Ma'am, their sides are equilateral, and then we have scalene and isosceles, ma'am.
Yeah. When based on the sides, we can classify triangles based on sides and based on angles. Based on the sides we have, when none of the sides are equal, we call the triangle
Scalene, ma'am.
In a triangle, when none of the sides are equal, all the sides have different lengths. All the 3 sides have different lengths. None of them are equal. So then we call the triangle a scalene triangle.
Scalene triangle.
Yeah, scalene. Scalene triangle. Scale and then any. Right, scale and then any. Scalene triangle. If in a triangle 2 sides are equal, any 2 sides are equal. 3 sides.
Isosceles triangle,
Any 2
ma'am.
sides are equal. It's called an isosceles triangle. Any 2 sides can be equal. It's called an isosceles triangle. And what's the third one?
Equilateral triangle with all 3 sides equal, ma'am.
Yeah, it's called an equilateral triangle. Equilateral.
Ma'am, this is the type in which all the 3 sides of a triangle is equal, ma'am.
Yeah. In an equilateral triangle, all the 3 sides are equal. In an equilateral triangle, all the 3 sides are equal. In an isosceles triangle, 2 sides are equal. Of the 3 sides, some 2 sides will be equal. And in a scaling triangle, none of the sides will be equal. All the 3 sides will have different measures. This is how we classify triangles based on their sides, based on the sides. Triangles are broadly classified based on sides and angles. Based on sides, we call them scalene triangle, isosceles triangle, and equilateral triangle. Based on angles, children, how do you classify them based on
acute angle?
Acute angle triangle, like obtuse
Obtuse
angle.
angle, ma'am.
Okay, so we call them so we call it if in a triangle all the 3 angles are acute.
Ma'am, acute angled triangle.
Ma'am, acute angle triangle, ma'am.
Just a minute, sorry. Yeah, children, sorry. Yeah, now tell me, based on the angles.
Ma'am, we are having acute angled, right angled, and obtuse angled. Ma'am.
Yeah, what is an acute angle triangle? How do you describe an acute angled triangle?
Ma'am, an acute
Ma'am,
angle,
the three angles are acute.
in an acute angle, all the three angles will be less than 90 degree, ma'am.
Why all should be less than 90? What if one angle is less than 90? Why can't we call it acute?
Ma'am, because acute angle is something that is less than 90 degrees, ma'am.
No, that's what. If one angle is less than 90 degrees, why can't we call it acute angle triangle?
Ma'am, because the sum will not be equal to 180.
Okay. No, like if I say 40, 50 and 80. No, 40, 50, 40, 60 and 80. The sum is 180, no? No, I have a doubt. My doubt is when it's a right triangle, what do we see? Okay, let's understand all the three and then I'll ask you this question. What is a right angle triangle?
Ma'am,
Ma'am,
right
only
angle
one
triangle
side will
is
be 90 degree, ma'am.
90 degrees, ma'am.
Okay, a triangle
And
in
the
which
two
one.
sides are acute, ma'am.
Okay, so a triangle in which one angle is a right angle and the other two are acute angles. Correct? Can all
Yes, ma'am.
the three angles be 90 degrees?
No, ma'am, that will not be because
Ma'am, that will not be.
ma'am, it
Why?
will be 50, ma'am. Ma'am, because when we sum up two of these angle itself, it will be 180, ma'am. So
Correct.
if we include the other side, it will be more than 180 degrees, ma'am.
Correct.
Ma'am, if there is also two 90 degree, it will not be a triangle, ma'am. It will be a square.
Correct. In a triangle, there can be only one angle with measure 90 degrees. There cannot even be another angle with measure 90 because there itself it will be 90 plus 90, 180. So the angle sum property of a triangle will not be satisfied. So it will not be a triangle at all. What about an obtuse angle triangle?
Ma'am, an obtuse
Ma'am,
angle
one should be obtuse, ma'am, and the both angles should be acute, ma'am.
but less than 360 degree. Another should be an acute angle, ma'am.
Less than how much?
Ma'am, it's like more than 90 degree and less than 180 degrees, ma'am.
Okay, obtuse angle.
Yes, ma'am.
Okay, so perfect. You've all defined the three types of the three triangles based on their angles perfectly. So in an acute triangle, so when you take an obtuse angled triangle, supposing this is 110 degrees, this is 110 degrees, and this is like say 50 degrees. This is how much? 20 degrees. So now you cannot call this just because this angle is an acute angle, just because 50 is an acute angle, or just because 20 is an acute angle, you cannot call this an acute angled triangle. One angle is more than 90 degrees. One angle is an obtuse angle. So this triangle is an obtuse angled triangle. So even if there are two angles, which are acute, since this angle is an obtuse angle, the triangle is called an obtuse angled triangle. Obtuse angled triangle. You are all right. I'm not saying anything new. All of you were right. So based on the sides, based on angles, we have acute angled triangle where all the three angles have to be acute. Acute angled, ANGLED, acute angled triangle is a triangle in which all the three angles are acute. That is, all the three angles measure less than 90 degrees. All the three angles measure less than 90 degrees. Next one is a right angled triangle. Right angled triangle. where one angle, not all the angles, only for acute angle triangle, we say all angles must be acute. In a right angle triangle, one angle, any one angle will be a right angle. Any one angle will be a right angle. Now this is the right angle triangle because this angle is a right angle. In an obtuse angle triangle, one angle will be more than 90 degrees, but less than 180 degrees. That is, one angle will be an obtuse angle. One angle will be an obtuse angle. Now, in a right triangle, once again, in a right triangle, if I call this PQR, in a right triangle, what do you call this side? What do you call this side?
Hypotenuse, ma'am.
Hypotenuse. Hypotenuse.
Ma'am, it's the longest side in a right angle triangle or opposite to the perpendicular, ma'am.
Correct. Opposite to the right angle. Correct. Hypotenuse. 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 This term is related only to a right triangle. This term is not related to any other triangle. The term hypotenuse is related only to a right triangle. Only in a right triangle, we have something called the hypotenuse. And the hypotenuse is a side. Hypotenuse is nothing but a side of the triangle. And it is the longest side of the triangle. In a right triangle, the longest side in a right triangle is called the hypotenuse. And that longest side always is the side opposite to the right angle. So see, this is the right angle. Opposite to the right angle, that side opposite to the right angle is called the hypotenuse. And that happens to be the longest side in any right triangle. See, supposing I have a right triangle like this. Which is the hypotenuse?
Ma'am, CB or BC. Ma'am, is it F or B, ma'am?
No, whatever you see there. Yeah, that's a triangle. Name the hypotenuse.
Ma'am, it's like the hypotenuse is CF or FC, ma'am.
Yeah, the hypotenuse is CF or FC. Because it's opposite the right angle. This is the right angle. This is a right triangle because you can see the angle here, which is marked 90 degrees. When it's marked like this, it means 90. It need not be written 90 there. If it's marked like this, it means it's 90. See, if it's marked like this, it's not 90. If it's a curve like this, it's not 90. If it makes a square like this, if it makes a square, if it makes a square
Ma'am,
like
it's perpendicular,
then
ma'am.
this is 90. This is 90. This is not 90. This is not 90. A curve like this does not indicate 90. Now A is equal to 90 degrees and CF is the
Hypotenuse.
because it is opposite to the right angle. What do you call the other two sides? That is in a right triangle. In a right triangle, the longest side is called the hypotenuse. What about the other two sides? What are they called?
Ma'am, like the perpendicular is it is one of the side which forms 90 degree, ma'am, and the base, the triangle in which they are formed at the bottom are said to be the base, ma'am.
Okay, correct. So this is this is called the base, and this is called the perpendicular.
Or height, ma'am.
Yeah. Perpendicular. All right, perpendicular. So in a right triangle, the longest side lies opposite to the right angle. The longest side lies opposite the right angle, which is called the hypotenuse. The other two sides. Now these two sides are called the sides containing the right angle. These two sides are called, that is PQ and QR. Can you see that? PQ and QR are called the sides containing the right angle. The sides containing the right angle. Do we understand? The sides. So the two sides containing the right angle are PQ and QR. Do we understand that, children? The two sides containing the right angle are PQ and QR. Do we understand that?
Yes, ma'am. Understood, ma'am.
The two sides containing the right angle are PQ and QR. Now, these two sides are also called the legs of a right triangle. They're also called the legs. They're also called the legs of a right triangle. So, which are the legs of a right triangle? The two sides containing the right angle are called the legs of a right triangle. And the other one is called the hypotenuse. So, in a right triangle, of the three sides, one side is called the hypotenuse. The remaining two sides are called the legs. Both one, each one is a leg. So this is a leg, this perpendicular is a leg. This base is another leg. Both of them are called legs. PQ is a leg, QR is a leg. So PQ and QR are the legs of the right triangle PQR. And PR is the hypotenuse. PR is the hypotenuse. PQ and side PQ and the side QR are called the legs of the right triangle PQR because they contain the right angle. Because these two sides only have the right, that is, they contain the right angle, meaning these two sides are the arms of the right angle. When we say that these two sides contain the right angle, it means that these two sides are the arms of the right angle. Check that for yourself. Right angle. An angle has two arms, right? An angle has two arms. Check the arms of the right angle. PQ and QR are the arms. PQ and QR are the arms of the right angle, and hence they're called the legs of the right triangle. So this is the angle. So this is one arm. This is one arm of the angle. This is the other arm of the angle. We all know arms of an angle. Arms of an angle. An angle has two arms.
Yes, ma'am.
Yeah, this is an angle. It has two arms. This is one arm. This is one arm. This is the other arm. Okay, so it's also called the base and perpendicular. QR is the base, PQ is the perpendicular, that's also fine. PQ and QR are called the legs of the right triangle and PR is the hypotenuse. We get that, children?
Yes, ma'am. Understood.
All right. Now, what is an altitude? In a triangle, what is an altitude? What's an altitude of a
Ma'am,
triangle?
it is the height of the triangle.
It's a perpendicular line which joins any vertex of the triangle to the midpoint of any side, ma'am.
Okay.
Ma'am, and in right angle triangle, it has a special property that one of its sides is an altitude, ma'am.
Yeah, one minute. Yeah. Oh my God, I made a mistake in spelling. Altitude, not attitude, okay? Altitude of a triangle. Okay. What is an altitude? In a triangle or an altitude of a triangle is the line segment. You should be careful in using the word line segment. Line has no length. A line has no definite length. It extends indefinitely on both the sides. A line has no length. It's a line segment. An altitude is a line segment because it has a definite length. An altitude is a line segment drawn from a vertex perpendicular to the opposite side. So let's draw that according to the definition. Now supposing I have a triangle like this. Okay. Now this is P, this is Q, this is R. Sorry, please. So PQR is a triangle. Now P is a vertex. What is an altitude? It's a line segment from a vertex perpendicular to the opposite side. Perpendicular to the opposite side. So PM is a line segment because you know it has a definite length. You can measure its length. It starts at P, it ends at M. It has a definite length. It has two endpoints P and M. PM is a line segment from the vertex P perpendicular to the opposite side QR. Perpendicular to the opposite side QR. Now M need not be the midpoint of QR. In the case of an altitude, M need not be the midpoint of QR. It's the altitude means it is perpendicular to the opposite side, or it's perpendicular to the base. You can see the line segment, I'm repeating. You can see the line segment PM starting from the vertex P, falling on the opposite side QR. It falls on the opposite side QR. The side opposite to vertex P is QR. It falls on the opposite side QR and it's perpendicular to QR. So PM is the altitude on QR. PM is the altitude on QR. Next. Take the vertex Q and QN. QN is a line segment from the vertex Q perpendicular to the opposite side PR. QN.
Shall I tell that QN is perpendicular to PR?
Yeah, QN is perpendicular to PR. QN is a line segment from the vertex Q perpendicular to the opposite side PR. And so QN is called the altitude on the side PR because it's perpendicular to that side. So it's called the altitude. It's falling from the vertex perpendicular to the opposite side. So that's the altitude on PR. So we say PM, symbolically we say PM perpendicular to QR. Then we say QN perpendicular to PR. Perpendicular to PR. Now, please, it's a line segment. Please excuse me. It can't be crooked like this, okay? The next one is we'll call it RT. Tell me what is RT? RT is a line segment.
Ma'am, RT is a line segment
From the vertex?
From the vertex of a triangle to
No, from the vertex. Which one? From which vertex? From the vertex?
R, ma'am.
R. Perpendicular to the
side PQ, ma'am.
Side PQ. Repeat that. RT is a line segment.
Ma'am, RT is a line segment which connects the vertex R to the line which is a perpendicular line to PQ, ma'am.
Yeah. RT is a line segment from the vertex R perpendicular to the opposite side PQ. So RT is the altitude from R on PQ. So we say RT perpendicular to, this is the symbol children for perpendicular. Perpendicular. RT perpendicular to PQ. RT perpendicular to PQ.
Ma'am, and the middle point of all these three altitudes are said to be a centroid, ma'am.
Okay, now the three the three altitudes, they go through the same point in every triangle. In every triangle, the three altitudes will go through the same point. That is, the altitudes are said to be concurrent. They are said to be concurrent. Concurrent means they pass through the same point. They are said to be concurrent. Intersect means when two lines meet, it's called point of intersection. When two lines meet at a point, it's called the point of intersection. Point of intersection. When more than two lines or more than two line segments, more than two lines or more than two line segments pass through the same point, it's called the point of concurrence. Point of concurrence. C-U-C-O and concurrence. C-U-R-R-E-N-C-E. Concurrence. Okay. So the three altitudes of a triangle are concurrent. They'll always go through the same point. Not in this case. Every time the three altitudes are always concurrent. They will pass through the same point. And that point is called the orthocenter. This point is called the orthocenter. Orthocenter. Just a minute, children. All right. So the point of concurrence of the three altitudes of a triangle is called the orthocenter. Orthocenter is the point where the three altitudes meet in a triangle. Got it, children? The point where the three altitudes meet in a triangle is called the orthocenter. Or it's also called the point of concurrence. The point of concurrence of the three altitudes of a triangle is called the orthocenter. So what is an altitude? It is a line segment from the vertex perpendicular to the opposite side. So here M need not be the midpoint of QR. M need not be. See, like QM can be some 5 centimeters. MR can be say 9 centimeters. M need not be the midpoint of QR. Similarly, N need not be the midpoint of PR. T need not be the midpoint of PQ. The angle formed there will be 90 degrees. This angle is 90. That is what is important. Is it fine, children?
Yes, ma'am. Understood.
Any questions?
No, ma'am, no doubt.
Point
No
of
doubts,
intersection is, point of intersection is when two lines meet. See, sometimes you will see the point, maybe they'll ask you the question like, what is the point of intersection of the three altitudes? So don't think that's a different question. Sometimes they don't use the word concurrent, they say intersection. So don't mind that, but that's the difference between the term intersection and concurrent. When exactly two lines meet at a point, it's called the point of intersection. When more than two lines pass through the same point, it's called the point of concurrence. It's not the point of intersection. It's called the point of concurrence. But having said that, supposing your teacher asks you the point of concurrence of the three altitudes in a triangle, don't think the answer is different. Just ignore that. Take the meaning as the point where they meet is called the orthocenter. Right. Next is centroid. Not centroid, sorry. Medians. Okay, medians of a triangle. Okay, so how many altitudes does a triangle have?
3 altitudes.
ma'am.
Has 3 altitudes. A triangle has 3 altitudes. Okay. And all the 3 altitudes will go through the same point. All the 3 altitudes will pass through the same point. Okay, now median.
Ma'am, a median is a line segment that connects a vertex of a triangle to the midpoint of the opposite side, ma'am.
Yeah. A median is a line segment. So like an altitude, a median is also a line segment. A median is a line segment from the vertex to the midpoint of the opposite side. It need not be perpendicular. So supposing you mark this point, you call this as M. Okay. And if M is the midpoint of BC, every side has a midpoint, no? AC, supposing the midpoint is N. And here, if the midpoint is O, okay, you can mark the midpoints for all the 3 sides. M, N, and O say are the midpoints of BC, AC, and AB respectively. If you join the vertex A to the midpoint M, then AM is the median. AM is the median. See, the median need not make 90 degrees with the side. Need not make. Need not. When it's median, it's only the midpoint. So AM is a median from the vertex A on the side BC. Why is it called a median? Because it's a line segment from the vertex to the midpoint of the opposite side. Similarly, BN, if you join the vertex B to the midpoint of the opposite side, it's called the median. BN is a median because it is from the vertex to the midpoint of the opposite side AC. Similarly, CO. All are line segments, children. Don't mistake them because the lines are slightly bent. They all are line segments. All of them are line segments. So CO is a median. CO is a median because it's a line segment from the vertex C. It's a line segment from the vertex C to the midpoint of the opposite side AB. Now the point of concurrence of the 3 medians of a triangle is called the centroid. It's normally represented by the letter G. Normally represented by the letter G. Centroid is normally represented by the letter G. Median is a line segment drawn from a vertex to the midpoint of the opposite side. It's a line segment drawn from the vertex to the midpoint of the opposite side. So M is the midpoint of BC, N is the midpoint of AC, O is the midpoint of AB. AM is the median. It need not be perpendicular to BC. It need not be perpendicular to BC. If we say that AM is the median, that means M is the midpoint of BC. That's all. If we say AM is the median, that means M is the midpoint of BC. Finished. CO is the median. That means O is the midpoint of AB. The three medians will go through the same point. The three medians will go through the same point. So the point of concurrence of the three medians in a triangle is called the centroid, normally represented by the letter G. Is that understood, children?
Understood, ma'am.
All right. Class, use the emoji. Raise your hand. All right, good. Okay. All right, so we discussed about altitudes and medians in a triangle. We all know that the sum of the three angles of a triangle is equal to 180 degrees, right?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now, we have a triangle ABC. The side BC is produced, say, to a point D. We have a triangle ABC. We have a triangle ABC. The side BC is produced, that is, it is pulled. It's produced, it's extended. It's extended, okay, to a point D. The side BC is pulled or it's produced at the point D. Now, when you produce any side of a triangle, an exterior angle is formed. Because these are called the interior angles. Interior angle, interior angle, interior angle. The three angles of the triangle. The three angles of the triangle are called the three interior angles of the triangle. The three angles are the three interior angles. The three angles are the three interior angles. When is an exterior angle formed? When a side of the triangle is produced. When a side of the triangle is produced, an exterior angle is formed.
Ma'am, or a line is extended.
Yes, Swati?
Ma'am, no, ma'am. An exterior angle is formed by which in one of the side is extended forward.
Correct, yeah. Now, every side can be produced in two directions. So you can produce a side BC like this. Okay, it's the same triangle ABC, okay? It's the same triangle ABC. When you pull BC, when you produce BC to a point D, an exterior angle is formed here. You can also produce CB, the same side CB. You can produce a side CB to a point E like this. Same side. See, you can produce a side in two directions. You can produce it like this. That is, we say this is producing BC to D. This is producing CB to E. The way we, use the name of the side. When we say BC produced, it is in this direction. When we say BC produced meaning in this direction. When we say CB produced, CB, we don't say BC for this. CB produced. So here we say CB. Side CB is produced to a point E. So the exterior angle is formed here. In the first figure, side BC is produced to a point D. And hence, so when is an exterior angle formed? When a side of the triangle is produced, an exterior angle is formed. In the second figure, the side CB, shouldn't say BC, side CB is produced to a point E. Side CB is produced to a point E. Same side it is. It's just produced in a different direction, opposite direction. Side CB is produced to a point E. And you can see the exterior angle being formed there. Now let's see the exterior angles formed by producing the other sides. Now, if you call this ABC again, you can produce. So let me show you all the 6 figures on the same slide, children, so then you will understand. 1 minute. So in these representations, you can see that I'll just name the triangle ABC everywhere. So you can see that every side can be pulled in 2 different ways. Everywhere it's triangle ABC. So here you can see that the side AC will come from AB. So see here, this is the side AB. Side AB. Okay, let me come from here. This is the side AB. Now side AB is produced. Can you see, children? Side AB is produced and an exterior angle is formed here. Yes or no?
Yes, ma'am. An exterior angle is formed.
Yeah, look at
Yes,
this figure.
ma'am.
So this is the first figure I'm talking about. Now I'm going to do this one. The same side AB, which can also be called BA. Now the same side here, AB is produced here, BA is produced. So BA is produced and you can see the exterior angle formed here, correct?
Yes, ma'am.
Okay, now see here, this is
Ma'am,
the
when the
third.
side AB, ma'am, when the side AB is produced, an exterior angle is formed here, ma'am.
Yeah, the first figure. In the third figure, side BC is produced and an exterior angle is formed. In the fourth figure, side CB, this is BC, this is CB. Side CB is produced. Side CB is produced and an exterior angle is formed. This is the fifth figure. Side AC is produced and an exterior angle is formed. And here the side CA is produced and an exterior angle is formed. That's all. Only these 6 ways we have. No other way. Every side can be produced in 2 different ways. AB, you can produce AB. See, in the first one, it is producing AB. In the second one, it's producing BA. Third one, it's producing, tell me, third one, we are producing which side?
Ma'am, for the third one, we are producing the side BC, ma'am.
And in the fourth one?
Ma'am, it's CB, ma'am.
We are producing the same side, but it's C in a different direction. So in the fourth one, we are producing the side CB. Fifth one?
Ma'am, it's AC,
ma'am.
We are producing the side AC. And in the sixth one?
Ma'am, it's like CA, ma'am.
CA. Now name the exterior angle, children, everywhere. In figure 1, if I call this point, I'm just calling this point E. I'm naming this point, children. There's an arrow here. There's an arrow here. I'm just marking a point on this. I'm calling it E. Now name the exterior angle. Use 3 letters.
CBE.
CBE or
EBC or
EBC. All of you should understand that. How do we name that angle? You can call it EBC or CBE.
Or within 1 letter, we can name it as angle B, ma'am.
No, we cannot say angle B. That's misleading. When it's angle B, is it the interior angle B or exterior angle B? When more than one angle is formed at a vertex, you cannot use a single letter. Now we can say angle A because at A there is only one angle. So you can say angle A. We can say angle C because at the vertex C there is only one angle. So there is no confusion there. When we say angle A, angle C, there is no confusion because at those vertices only one angle is formed. But when more than one angle is formed at a particular vertex, we need to be very specific when we name the angle. So when we say angle B, all of us will get a doubt. Is it this angle B or this angle B? So it is important to name using 3 letters at vertices where more than one angle is formed. So if we are referring to the interior angle B, we must say what, children? The interior angle B is called in the figure 1. In figure 1,
ABC.
Yeah, the interior angle B is called ABC or
CBA, ma'am.
CBA. So it is the interior angle B is called ABC or CBA. The exterior angle here is called EBC. See, this E is here, children. This point is E. That's what I meant. This point is E. So EBC or CBE.
EBC or
CBE. We should not say simply angle B because it's not specific when we say angle B. In the second figure, children, name the exterior angle formed in the second figure.
The exterior angle is CAF or FAC, ma'am.
Yeah, CAF or FAC. In the third figure, see, I'm just using an arrow. I've produced a line, right? So I'm just indicating it by producing. We have produced it, so this arrow. And then I'm just taking a point on that ray and giving it some name. Yeah. Name the exterior angle in figure 3.
ACG or GCA, ma'am?
C.
Correct. Yeah, and for figure 4, the exterior
Ma'am,
angle.
ABO or
and
OBA, ma'am?
OBA.
Yeah, ABO or OBA. In the 5th one,
Ma'am, it is
Ma'am,
BC.
ACX or XCA, ma'am?
no.
Ma'am, BCX and XC.
I've
Do
used
you
a
know,
small
ma'am?
letter X, children. No, I've used a small letter X to indicate the angle itself.
Oh, yes, ma'am.
So
If
the
it is
exterior angle is.
capital letter.
So what is the exterior angle there?
X, ma'am.
X.
X, ma'am.
Yeah, X is the exterior angle. We don't use, because we know that a point is always named using a capital letter. A point, if you take a point, you should always name it using a capital letter. No small letter for a point. No small letter for a point. So this one is X. This one is X. See, actually it is X, but in some books you will find angle X. It's not angle X. We don't use the symbol angle when it's a small letter. But I'm just telling you so that you don't get confused. You can see this in some books, but it's simply X. X is the angle. The angle is the exterior angle is X. That's all. The exterior angle is X. We use this angle symbol only for capital letters and for numbers. If I number this 3, which is the exterior angle? Angle 3. You shouldn't say simply 3. You should not say simply 3. See, this angle, can be, we saw the different ways of calling the exterior angles using the letters. Now, if I call this exterior angle itself using a small letter, then it is X. This exterior angle, if I call it using a small letter, then the exterior angle is X. But if I use a number for the exterior angle, not only for the exterior angle, any angle I'm saying. So here it is the exterior angle. If I use a number, then you should not say 3 is the exterior angle. You must say angle 3. Angle 3 is the exterior angle. So when angles are named using numbers, then you must use the angle symbol. Angle 3, angle 1, angle 2. But if a small letter is used, X, Y, Z, A, B, C, simply X. The exterior angle is X. The exterior angle is Y. And so on. So this is about exterior angles, children. Understand?
Yes, ma'am. Understood.
Yes, ma'am.
All right, children. Now coming to the exterior angle property in a triangle.
And sum of the opposite angle of an interior angle is equal to the exterior angle, ma'am.
Come again?
No, ma'am. The sum of these exterior angle is equal to the opposite angles of an interior angle.
No,
Angles.
I understand that you've understood it, but not in some of the exterior angles. It's okay, fine. We'll see that. We'll see how to say that. You have understood probably, but we'll see how to say that. Now, children, let me take some numerical example. I'll call this, say, 60 degrees. Okay, let me say this is 60 degrees, okay? And let me say this is 40 degrees. Now, children, find the measure of angle X. Find X, children. Find X, children.
Ma'am, 90.
Children, okay, sorry, this is 60, ma. This is 60.
Ma'am, 80 degrees.
80.
How do we work that? Tell me the steps. How
Ma'am,
do we work it?
Ma'am, 50 plus 40.
Yeah.
Ma'am, it's like 50 plus 40, sorry, 60 plus 40 is equal to 100. And then that 100 should be subtracted from 180, ma'am. So we get it as the angle is 80 degrees.
Okay, but I think you can do it like this. 60 plus 40.
Plus x is equal to 180.
Yeah, plus x is equal to 180. We know we say that in words, no, the sum of the three angles. So the sum of the three angles of a triangle is equal to 180. That's what we say. Write the same thing. The sum of the three angles, all the three angles. The sum of the three angles, 60, 40, and x. 60 plus 40 plus x is equal to 180. 100, tell me, 100.
100 plus x is equal to
180 degree, ma'am.
180. Then
Ma'am, x is
Ma'am,
equal
and then
to
100 is 100 x is equal to 180 minus 100
100.
degrees, ma'am.
180 minus 100.
100.
And then x is equal to 80 degree.
Yes, ma'am.
Equal to 80. X is equal to 80 degrees. Now, supposing I had not given this x here, then you should use angle ACB. Instead of x, you should say angle ACB or angle BCA. No, I'm just telling ACB, yeah. No, I'm just telling you, supposing this letter x was not given, then you must say 60 plus 40 plus angle ACB. Or you should say plus angle BCA is equal to 180. Correct?
Yes, ma'am.
Okay, all of you remember x is 80 degrees, okay? Now find y, children, using linear pair. Find y using linear pair.
100,
What is x
ma'am,
plus y?
is equal to 180 degrees, ma'am.
Do we all know x plus
Ma'am,
y
and
is
in
equal to
bracket,
180?
yes, ma'am. Ma'am, and in bracket, we can write it as linear pair.
Yeah. Okay, x plus y is equal to 180. What is the reason why x plus y is 180?
Ma'am, because it's
Ma'am,
linear
because
pair,
it's
ma'am.
supplementary linear.
Linear pair. They stand on the straight line. The two angles are on the straight line. See, this is straight line. These two angles, they stand on the straight line. So what is x? 80. So 80 plus y. 80 plus y is equal to?
Y. 180 degree.
180
So what is
degrees,
y?
ma'am.
Y is equal to
100, ma'am.
180 degree
Y
minus
is equal to
80
100
degree.
degree, ma'am. 180 degree minus 80 degrees, ma'am.
180 minus 80, which is 100 degrees.
Yes,
So what do you notice? What is the value of y? Y
100
is
degree.
100 degrees, ma'am.
It's nothing but 60 plus 40, right?
Yes, ma'am.
Yes, ma'am.
See, to find y, what is the value of y? Y we get is 100. And that's
100.
60 plus 40. So we say that the exterior angle of a triangle. This is the, okay. This is called the immediate interior angle. For this exterior angle, this is called the immediate interior angle. Immediate interior angle. These are the interior opposite angles. Let me clear the slide. These are the three exterior angles. I'm sorry, interior angles. These are the three interior angles. For this exterior angle, this is the immediate interior angle. Immediate interior angle. The remaining two are called the interior opposite angles. Which is the exterior angle? which is the exterior angle?
X, ma'am. Ma'am, X, Y, and Z.
Exterior,
sorry.
which is the exterior
P,
angle?
P, ma'am. I thought you were saying interior angle.
Why, children? All of us should get the same, give the same answer, right? Now tell me again, which is the exterior angle?
P, ma'am.
All of you, P, right?
Yes, ma'am. P.
Now tell me all the three interior angles. All the
Ma'am,
three
X,
interior
Y, and
angles.
Z.
X, Y, and Z are the three interior angles. Now, which is the immediate interior angle for P?
Y and Z are the immediate interior angle for P,
No,
ma'am.
Swati, no. The immediate interior angle for P. P and what forms a linear pair?
X, ma'am.
That is the immediate interior angle. X is the immediate interior angle. Immediately, which is the interior angle? X. P and X form a linear pair, right? P and X only form a linear pair. So for P, X is the immediate interior angle. Which are the two interior opposite angles?
Ma'am, then only it will come as angle Y and Z.
No, please answer the question. Which are the two interior opposite angles?
Y and Z, ma'am.
Y and Z. The immediate interior angle for P is X. So we have two interior opposite angles, Y and Z. Y and Z are called the interior opposite angles. So the exterior angle P, we say the exterior angle P is equal to the sum of the two interior opposite angles. Interior opposite angles. P is equal to Y plus Z. If you want to find the measure of P, it is equal to Y plus Z. P is equal to Y plus Z. Exterior angle is P. Y and Z are the interior opposite angles. The property is exterior angle is equal to the sum. That's why plus. Exterior angle P is equal to the sum of the two interior opposite angles. Which is the exterior angle?
X, ma'am.
X is equal, exterior angle X will be equal to?
B plus C, ma'am.
Next to X, what is the interior angle just next to X? A. Leave that one. Leave that A. X will be equal to B plus C. X will be equal to B plus C. No, the others also must say.
X plus
Which is the exterior? Somebody else, not Swati. Somebody else tell me, which is the exterior angle?
Ma'am, can I say?
Yes, Matthew, what is the exterior angle?
A plus C, K, ma'am.
No, this is not K. 1 minute, this is X. 1 minute, this is X.
A
This is
plus
N.
X.
This is N.
Okay.
Which is the name the exterior angle?
M, ma'am.
M is the exterior angle. 1 minute. M is the exterior angle. M is equal to
A plus X, ma'am.
A plus X. Matthew, which are the three answer the question. Which are the three interior angles of the triangle?
Ma'am, N, A, X, ma'am.
They are the three interior angles. Which is the exterior angle formed here?
M, ma'am.
M. Now the property is the exterior angle is equal to, that is M is equal to the sum. That's why we are adding the sum of the two interior opposite angles. Interior opposite angles.
Okay,
So
ma'am.
this is the immediate interior angle. Interior opposite angles are A and X.
Okay, ma'am.
For M, N is the immediate interior angle. So you should leave that. You should not use that. A plus X.
Yes, ma'am.
I hope all of us understood this property.
Understood, ma'am.
It is said like this. The exterior angle of a triangle is equal to the sum of the two interior opposite angles. Interior opposite angles. All right, children. So that's it for today's session. Thank you so much.
Thank
You
you,
may
ma'am.
leave the meeting. You may leave the meeting, but just a minute,
Thank you,
children.
ma'am.
I just need to ask you something. Just a minute.